Hello everyone, I am Dr. Sirajullah Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about quantum chemistry. Quantum chemistry is the application of quantum mechanics to solve problems in chemistry. It has been applied in different branches of chemistry like physical chemistry to calculate thermodynamic properties, interpretation of molecular spectra and molecular properties like bond length, bond angles, dihedral angles, etc. Quantum chemistry also applied in organic chemistry to estimate the relative stabilities of molecules and reaction mechanisms. It is also useful in analytical chemistry to interpret of the frequency and intensity of line spectra, and of course in organic chemistry to predict and explain of properties of transition metal complex. Now, the role of quantum mechanics in chemistry. Quantum mechanics, and classical mechanics. So, classical mechanics to quantum mechanics to quantum chemistry. This is the growing. Applied in physical, inorganic, organic, photochemistry, polymer, surface and catalytic, drug design, and toxicity. Historical background of quantum mechanics. Nature of light. Hertz 1888 has shown that light is electromagnetic wave, where lambda is the wavelength, c is the speed of light, v or nu is the frequency centimeter per second. Max Planck has assumed only certain quantities of light energy could be emitted, E is equal to h nu, where h is Planck constant, the energy is quantized. Photoelectric effect, light comes out by shining surface in vacuum. In 1905, Einstein light can exhibit particle-like behavior. Light can exhibit particle-like behavior called photons. So, E photon is equal to h nu is equal to W plus half mv square, where W is work function, minimum energy required to take electron out, and half mv square is the kinetic energy of emitted electron. From above, it is assumed that light look like a particle and wave. So, nature of matter. Rutherford and Giger have found that some alpha particles bounce right back from golden foil, have a small positive nucleus in atom. So Bohr has studied the hydrogen atom and assumed that the energy of electron is quantized. So where nu is the frequency of absorption or emitted light, del E is the energy difference between two states. So de Broglie has suggested that the motion of electrons might have a wave aspect. Lambda is equal to h by mv, h by hp, where m is the mass of electron, p is a particular momentum. Accordingly, it has been suggested that electrons behave in some respect like particle and some other like wave, and this is what is called a particle-wave duality. The question arises: how can an electron be a particle, and which is localized entity, and a wave which is non-localized? So answer is no, neither a wave nor a particle, but it is something else. The classical physics has failed to describe the microscopic particle. So the question arises: how can an electron be a particle which is localized in entity and wave which is non-localized? So answer is no, neither a wave nor a particle, but it is something else. So Heisenberg uncertainty principle. It is impossible to determine precisely and simultaneously the momentum and the position of an electron. The statistical definition for the uncertainty is del x, uncertainty in position, and difference in uncertainty of momentum greater than is equal to h cross by 2 or h by 2 pi, where h by 4 pi. So wave functions. To describe the state in quantum mechanics, we postulate the existence of a function of the coordinate called wave function. State fit, you can see psi is equal to psi x and t. What is the x and t? So it contains all information about a system. The probability of finding a particle in a given place can be given by the probability description. So what psi x means? Psi is an amplitude, sometime complex function, not measurable, imaginary value. Psi star is a complex function which may be real and possible. Psi has no physical meaning, but psi star is the probability of locating the electrons at a given position. If the probability of certainty is defined as unity, this means if we have two different wave functions, psi 1 and psi 2 will be normalized function when if or the function is called orthogonal function. But if where called Kronecker delta is equal 0 when I is not equal to j and equal 1 when I is equal to j, the relation is called orthonormalized functions. So time dependent Schrodinger equation. We postulate existence of a function of coordinate called the wave function, means a state function, psi, for one particle and one dimensional system. You can see here psi is equal to psi x and t. So this x and t, this is a probability description. It contains all information about a system. The probability of finding an electron, finding a particle in a given place can be given by psi probability description. Born postulate module of psi xt square dx is the probability of finding particle at position x and the time t, probability density. Psi must satisfy Schrodinger equation. As t passes, psi changes to differential equation. So minus h cross by I dou psi xt dou t is equal to minus h cross square dou square divided by 2m psi xt divided by dou x square plus vxt psi xt. So where I is equal to and m is equal to particle mass and v and xt, v xt potential energy, v is potential energy at time and position, and this is called time dependent Schrodinger equation. So Schrodinger equation can be solved by technique called separation of variables. The partial derivatives of this equation, making the substitutions in equation 2, dividing by and taking the left side of equation 3 on integration in its constant of integrations. So one of the properties of a function, it is complex, that is, it is possible to conjugate. So called, you can see probability density time dependent wave functions. Something here missing.